Morning students, welcome to chemistry class. Today I am going to be discussing about from chapter 2 structure of atom. Yesterday class continued shapes of orbitals. So yesterday completed shapes of orbital, s orbital and p orbital, and now today I am going to the d orbitals. Shapes of d orbitals. Okay. So there are 5 d orbitals. Namely dxy, dyz, dxz, dx square minus y square, and dz square. So all these orbitals have same shape and different orientation. Okay, so these 1, 2, 3, 4, they 4 are have same shape and different variations, but fifth one is different shape and orientation. Okay, so here all these d orbitals have directional. Okay, so all these are directional. Okay, now then here we draw the shapes of orbitals. This is z axis, and this is x axis, this is y axis. Okay, so here it is the z axis. First one is dxy. This orbital is dxy. So the lobes are along the side of the x and y. Okay, so this is the y. Okay, and this is the x. Then so this is the x. Okay, so along this x, these two lobes are present. So this is double shape. D orbitals have double dumbbell shape. Okay, so this is the lobes. Okay, so this is along on the y axis, and this is on x axis. Okay, then another one is dyz. Okay, so this is x, this is y, this is z. Okay, this is z. Right? So here this dyz. Okay, so dyz means on z, on z1, on y, okay, so this is for while and to this Z this is Y. Then here X, this is Y, this is Z, and XZ. So XZ. So this is X, this is X in this XZ. This is for Z and this is for X. This is for X. Okay. Then and all are similar shapes. All are similar shapes. Z. And this is for Y. Okay, like this. D, Y, Z. And another one is like this. Okay. X square minus y square, x square minus y square. This is y, this is x, this is z, and along with this, and z along with this. Okay. So this is dx square y square and dz square, that is this is z, y, x, and here z square. Both rows are on z, so that's why this is shown like this. Another one shown like this. Okay. Another one show like this. This is the dz square. So the structure of d orbitals like this. This is dxy, this is dyz, this is dxz, this is dx square and minus y square, this is dz square. Okay. So here this is the plane, this is the directions, these are the directions. Okay. So here at the center two lobes are there, so this is that is the probability of finding electrons is 0, that is a node. So what is the nodes? Already know, and once again you will discussing about the nodes. Here the node means the region where the probability of finding electrons is 0. That is called a node. Okay. So that is the probability density function is 0. The probability density function is 0. Okay. At the node, the probability of function, the probability density function is 0 at the node. Okay. So the node may be radial or angular. The node may be radial or angular. Radial means it is spherical, is it? That is radial node. It is no spherical is there. That is angular. Means planar. Okay. So radial or planar. So it is spherical. That is radial. It is suppose if it is the planar, that is angular. That is angular nodes. Okay. So suppose examples. In case of 2s orbital, a spherical region in which a probability of finding the electron is 0. Okay, it is a radial node. So this is the 2s orbital. This is the 2s orbital. Okay, so this is the nucleus. So this is first space around this. Then here like this, and another space like this. Okay, so this is the empty space is there. So this is a node. So this is a sphere. So that's why this is called radial node. This node is radial node. The third node is radial node. Okay. It is present in 1s, 2s orbital have one radial node. So like this, in case of each p orbital, there is a plane where the probability of finding the electron is 0. There is a plane where the probability of finding the electron is 0. It is an angular node. Okay. So this is the p orbital of any p orbital. Okay. So this is low. This is direction, x direction, y direction, and z direction. Okay. Then here this is the planar or angular. Okay. So here one node is there. That is angular node. Okay. This is for p orbital. So this is sphere. So radial node. This is planar. So this is angular node. So how to find out the angular node and the radial nodes? Okay. So total number of nodes in any orbital we know already, that is n minus 1, given by n minus 1. For any orbital, total number of nodes in any orbital is given by n minus 1. Okay. So number of angular nodes equal to n. Number of angular nodes equal to n. So n values. Okay. So therefore, number of radial nodes equal to n minus 1 minus n. Number of radial nodes equal to n minus 1 minus n. So for examples we have to take the examples. First example, for 1s orbital, n equal to 1. For ns orbital, n equal to, if it is n equal to 1, so n equal to 1 for 1s, n equal to 1. Okay na? So it does not have any nodes. Why? Because n minus 1 equal to 0. Why? Because n equal to 1, 0. So that is the 0. N equal to 1 is there. So n minus n 1 minus 1 equal to 0. So that's why they does not have any nodes. So that is the 0. Suppose we consider 2s orbital. For 2s orbital, n equal to 2s means 2 means what? N equal to 2. 2 means n equal to 2. So for 2s, n equal to 2. So 2 minus 1 equal to 1. So 1 node is there. So 1 node is there. Okay. So 2s, it has 1 node since L equal to, so here L equal to 0. In S orbital means L equal to, there is 0. So that's why there is n minus 1 minus L. So 2 minus 1 minus 0, that equal to 1. So this one is a radial node. So that is it does not have any angular node. It has one radial node. Okay, na? One radial node. Then another one is third example. We'll take third example. For any 2 orbitals, for any 2p orbitals, n equal to 2. For any 2p orbitals, n equal to what? 2. For any 2p orbital, n equal to 2. So n equal to what here? P orbitals means 1. L equal to 1. So that's why we take here n minus 1 minus L. So n equal to 2 minus 1 minus 1. So minus 1 minus 1 2. Okay. So 2 minus 2. So what happened? This is 0. So means radial node is 0. But angular node is 1. Okay. For 2p orbital, n equal to 2, n minus 1 equal to 1. It has a one node, but L equal to 1. It has one angular node. Therefore, it has one angular node. So it is radial nodes is 0. Okay. Here radial nodes is 0. You understood? Okay. So 2p orbital is there. Number of nodes are here n minus 1, that equal to n minus 1 equal to here how much? So here 2 minus 1 equal to 1. So one node is present in this. Which type of node there? Radial node or angular node? Angular node. Why? Because radial node means radial node equal to n minus 1 minus L. Okay. So 2 minus 1, L equal to here 1. L equal to P means what? L. So L equal to 1. So that's why 2 minus 2 equal to 0. So this is a radial node is 0. But the node is there. So which type of node is there? Angular node. Okay. Angular node. Right? So this is the third example for that one. So here shapes of the orbitals and nodes. How to calculate it? Nodes by for using this for given any orbitals. For any orbital, we will calculate nodes n minus 1. For radial nodes, n minus 1 minus L. That is using for the radial nodes. Okay. Then here a graph of wave function radial wave function versus distance from the nucleus for 1s and 2s orbitals. So for 1s orbital, this is 0, this is y axis, this is x axis. So this is distance increases here. This is side r. So wave function of radial like this. Okay. So the curve like this only means this is always positive. Always positive. And for 2s orbital, this is the graph when distance increases. When distance increases, the graph decreases, and when reach that 0 position, and that negative sign, positive sign changes to negative sign. So at where it is the changes, that point is the probability of finding electrons is 0. That is known. Okay, so that's why this is in 2s orbital positive sign, and positive means what here? The electron probability near the nucleus and away from that nucleus. Okay, negative sign away from that nucleus. Okay, and another one is here for 2p orbitals, the distance is increases from the 0 and then decreases like this. So this is one of the low. Okay, so this is the p orbitals, and we have to see psi square r. So the graph between distance and psi square r, that is decreases like this for the orbital. So this is shows there is no nodes. Okay, and here psi square r. Okay, so this is distance like this. When increasing the distance from the nucleus, that the graph will be decreases and touch to the 0 position. 0 position means that when it is touches that is the probability of finding electrons is 0. That is a node. And again increases that graph along with the psi square y. This is the probability of finding electrons or density of wave function to the finding the electrons. Okay, so increases like this. So means this is have one node present in a 2s orbital. This is explained. One node present in a 2s orbital. So this is the graphs of wave function radial versus distance from the nucleus for 1s and 2s orbitals. For 1s wave function is always positive, and for 2s one is positive, another one is negative. Where the changes the positive to negative, that position is probability of finding electrons is 0. That is a node. So in this situation we have to see the p orbitals also. Okay, so this is the shapes of orbitals and graphs of the orbitals. Okay, thank you watching this video.